Morning, students. So today we are going to solve Feb March paper of 2026. Okay, so I recommend you whenever we are doing the question, first pause it, try to solve it yourself, and then see the solution. Okay, so you can learn something from it. ताकि जब आप मई जून के एग्जाम में बैठे तो दैट थिंग विल बेनिफिट यू सिर्फ आपने देखना नहीं है ओके सो व्हाट यू हैव टू डू व्हेनेवर आई एम स्टार्टिंग द क्वेश्चन यू हैव टू पॉज द वीडियो यू हैव टू सॉल्व इट योरसेल्फ देन यू हैव टू कम बैक if you have any question if you have any problem comment okay I will respond to you कोई क्वेश्चन है आप डिस्क्रिप्शन में जा सकते हैं मैं इसका लिंक भी शेयर कर दूंगा वहां पे यू कैन डाउनलोड द सॉल्व्ड पेपर फ्रॉम देयर और अगर आपने चैनल को अभी तक सब्सक्राइब और लाइक नहीं किया ऐसे तो प्लीज सब्सक्राइब इट ताकि जब मैं नेक्स्ट पेपर्स अपलोड करूं इसके डिफरेंट कंपोनेंट्स तो यू गेट द नोटिफिकेशन फॉर इट ओके थैंक यू लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन First question is, what is the value of the ratio 1 kilometer or over 1 nanometer? So what you simply need the knowledge of prefixes. We know 1 kilometer over 1 nanometer. Kilo is 10 power 3 and nano is 10 power minus 9. Okay, so you can simplify it. There is one way. This power minus 9, when this thing will go up, it will be plus 9. Okay, so it will be 1 over 10 power 3. मैं बहुत डिटेल में सॉल्व करूं because sometimes students stuck into it. कुछ students बहुत अच्छे से कर लेते हैं, but I know some students feel difficulty when dealing with the power. So what is happening now? The powers bases are same, powers will be added up. 3 plus 9, it will give you 1 into 10 raised to power 12. So what we have, it is 10 power 12. It's option D you have. Okay. Okay. Next question. Question 2. What could reduce systematic error? Okay. If you remember, there are two types of error. एक systematic है, एक आपके पास second is the random error. Systematic error apparatus में होता है. So if you have to remove that error, what you have to do, careful calibration of measuring instrument. ठीक है, ये A नहीं हो सकता क्योंकि averaging a large number of measurement will reduce the random error. Okay, same as C and D is also irrelevant. Question 3. A student measures the current and the potential difference of the resistor in the circuit. They have given you the current, they have given you the potential difference. पूछा क्या जा रहा है जी आपसे द मेजरमेंट्स आर यूज्ड टू कैलकुलेट द रेजिस्टेंस ऑफ द रेजिस्टर व्हाट इज द परसेंटेज अनसर्टेनिटी इन द कैलकुलेटेड रेजिस्टेंस आपने रेजिस्टेंस में कैलकुलेटेड अच्छा फर्स्ट यू नीड टू नो द फार्मूला में पता है कि R इज इक्वल्स टू V ओवर I होता है एंड व्हाट इज द बेसिक व्हाट यू कैन से मेथड टू फाइंड द परसेंटेज अनसर्टेनिटी जब भी कोई वैल्यूज आपस में मल्टीप्लाई या डिवाइड हो रही होती हैं फिजिकल क्वांटिटीज उनकी परसेंटेज अनसर्टेनिटीज ऐड होती हैं हमेशा ओके so what you do we can say percentage let's do it here percentage uncertainty of R will be equals to percentage uncertainty of V plus percentage uncertainty of I okay अच्छा V की परसेंटेज अनसर्टेनिटी अगर मैं लिखूं इट विल बी डेल्टा V ओवर V अच्छा लेट मी राइट इट डाउन हियर दिस इज डेल्टा V दिस इज V दिस इज डेल्टा I दिस इज I so it will be delta V over V plus delta I over I and this all thing will be multiplied with 100 so now you just have to put the values when you put the values you will get delta is 0.1 divided by 500 plus 0.01 divided by 50 and they will be multiplied with 100 and you get the answer 0.04%. Okay, so we don't have the marking scheme for this paper right now, so solve it carefully and you can match your answers. Okay, question 4. Graph can be used to represent the motion of an object. Okay, which relationship between a quantity of motion and property of the graph is true? In first, acceleration is the area under velocity time graph. That is totally wrong. Acceleration is gradient of velocity. Yes, it is. Okay, it's a very easy question. Question 5. The water surface in a deep well is 78 meter below the top of the well. A person at the top of the well drop a heavy stone down the wall A resistance is negligible. It's mean you can say A is equals to G, acceleration G की equal होगी, the speed of the sound in the air is given. Okay, what is the time interval between the person dropping the stone and hearing it hitting the wall? Okay, so let's first try to understand the scenario. What we have, let's suppose this is a well, and this is the ground. Okay, I say this thing is the well, and I say the person is standing here. When he dropped the stone, let's suppose this is the stone, it has to go down, all the way go down. This is the stone dropping to the bottom. So first there it will take some time. Let's call this T1. So what they are asking, you have to tell what is the time interval between the person dropping and hearing it hitting the water. So now it, when it will hear, when the sound will reach the person from the bottom of the wall, so from there the sound will go up and up and up like this, the wave, and then it will hear the sound. This, let's suppose this time is T2. Okay, what we have to find, we have to find T. T is basically T1 plus T2. Okay, so T1 आई एम सेइंग कि T1 वो टाइम है जिसमें स्टोन डाउनवर्ड्स जा रहा है. तो हाउ मच टाइम इट विल टेक, वी हैव अ बेसिक रिलेशन V is equals to distance over time. So time is equals to distance over speed. So let's take this distance is given, this is 78, that is 78 divided by speed of the stone. There will come speed of stone. Okay, and we don't know it what it is. Okay, as a second T2, how we can find T2 is 78 divided by speed of sound, and we know this 78 divided by 330. So when you divide 78 with 330, I will get 0.23 second. Okay, what I have to find, I have to find speed of the stone. Okay, what information I have? It's a free fall motion. Acceleration is equals to G. So there are different ways. You can also apply the equation of motion as well, or you can simply apply here the energy conservation. At this point, the stone have the potential energy, and at this point, all the potential will change into kinetic energy. So I can say that the loss of kinetic energy will be equals to gain of potential energy because there is no air resistance. Okay, so when we put the relation here, it will give you 1 by 2 mv square is equals to mgh. This and mm cancel, this v can be written as 2gh in the root. Okay, so when I put the values, I know g is 9.81 and h is 78. What I will get? 39.11 meter per second. Okay, what this is the final speed. At this time, when it started, the stone, the speed was here 0 initial. At this point, when it hit the ground, its speed is basically equals to 39.11 that I have calculated. Okay, this is the VF when it reached the ground. Okay, to calculate the time taken, I need the average speed. Okay, this is the one of the mistakes students do. You need the average speed. How we can calculate the average speed? Simply V1. Okay, let's call this speed V1. Okay, so V1 is equals to Vi plus Vf divided by 2. So 0 plus 39.11 divided by 2. I'm getting the average speed. It will give me 19.55. Okay, now what I can do, I can put this thing, this speed here, so I can back substitute. So I can write it down, T1 is equals to 78 divided with the speed, that is 19.55. When we divide this, we will get 3.98 second. Okay, so we have T1, we have T2. We know T is equals to, our answer is T1 plus T2. T1 is 3.98, T2 is 0.23. That thing will give you 4.219. That can be written as 4.22. Okay, so it's option D, that is correct. Okay, moving forward, question 6. Question 6 is, a toy car move in a straight line. The graph shows the variation with the time of the displacement of the car from its initial position. What you have to tell a student, investigate whether the forces acting on the car are in equilibrium at four different. Okay, at which time are the forces acting on the car is in equilibrium? Okay, so for the equilibrium, what we know, resultant force should be equals to 0. So its mean acceleration should be equals to 0. Its mean velocity should be equals to constant. It should be constant, whatever the value is. Okay, so what at which time are the forces? Okay, they're not asking the interval, they're asking the exact time. At which time? Okay, so at this time, the slope is straight, horizontally straight. So there is no change in velocity. If you see at t2, the slope is also straight here. There is no change in velocity. There is some positive velocity. It's not zero, but it's not changing. Okay, velocity slope is constant velocity, so it is also zero acceleration. Same is this point, that is t3, and same is this point, even if it has a negative velocity or something, but still it has a constant velocity. Okay, it's not changing, so it's not accelerating. So it's option A, that is correct. Moving forward, question 7. A car travel anti-clockwise along a horizontal circular road of radius 12 meter, and a car take this much time to move from P to Q. This is P and this is Q. Okay, this is moving anti-clockwise. It's covering all the way this distance and it's reaching back at Q. Okay, so what is the magnitude of average velocity of the car from the journey? Okay, very interesting. So velocity is vector. You have to keep in mind the comparison of speed and velocity. Velocity is a vector quantity. It depends on not the distance. It depends on displacement. And displacement depends on initial and final position. So it is initially at P, finally at Q. So what is the displacement? This is from P to Q, this straight line. Very easy. Okay. So you know this thing, you can write down this as, this will be under root 12 square plus 12 square. Okay, this will also be 12. This is the hypotenuse, right? So this will be the length of this line, the displacement. Time you already have, this is the time. So you can find the average velocity, right? So velocity is 12 square plus 12 square divided by the time that is given. It's 4. So you will get 4.24. So it's option A. Moving forward, question number 8. A person is suspended from a rope vertically below a helicopter, and a helicopter and the person are stationary above the ground. Okay, so they are not moving. Which force form a Newton third law of force pair with the weight of the person? Okay. And what you have to keep in mind, beta, whenever they ask you about the third law, there are only two objects involved. Okay, this is a very common mistake. Let's suppose there is object A is doing action on B, so B will do reaction on A. This action and reaction is basically the force. Okay, so let's suppose if they ask you about the weight, weight is basically force of Earth on the person. This is the action. So what the reaction is? Reaction should be force force of earth, or you can say force of, I should say force of gravity. So force of gravity on earth by person, that will be a reaction. So okay, so it's C, the gravitational force applied by the person on the earth. Okay, moving forward, question 9. Two small moving particles collide. After collision, the particle move in different directions. Okay, what is the essential for the total momentum to be conserved in the collision? Okay, no external force act on the system of the two colliding particles. Yes, this is essential. Okay, the system should be isolated, it should be a closed system. Okay, B is no kinetic energy lost. This condition is for the elastic. They are not asking you the elastic. You have to keep in mind momentum is conserved in all the collisions. Whenever the system is closed, the momentum will be conserved, whether it is a elastic collision or it is a inelastic collision. So this can be true for elastic, but for momentum to be conserved, this condition is not required. The collision is inelastic. The relative speed of this is also for the elastic collision, the D option. Okay, so the only option A is correct. Moving forward, question 10. Block A of mass 3 kg is on horizontal frictionless table. A rope with negligible mass is attached to the table. Okay, so the rope passes over a frictionless pulley. The block 2 mass you also have. Okay, the block then accelerate. Acceleration of the free fall is g. The unit of is given, and the tension in the rope is equals to this has the unit Newton. What is the tension in the rope in the term of g? Okay, so this is a typical question where the two objects are attached with each other. Okay, and they're accelerating. You have to find the tension. There will be a tension force. Let's organize the data that we have. You have to find this tension. Okay, what we have mass of this block. So there will be a weight acting on it. There will be a force. The force is weight basically. What is the mass of block 2? It's 1 kg. So force will be 1 into g. If you, this is not the unit g, this is the g for the gravitational fields. Now if you remember, weight is equals to mg. Okay, acha, so what we have masses of both. There are a few points that I want you to write it down for your exam. Whenever, the basic trick is, let me write it down here. The trick that you need to keep in mind: acceleration uses total mass. Mean when you have to find the acceleration, you have to deal with the both the masses. But forces, force equation use what? It use individual mass. Okay, this point will be clear to you when I will solve this problem. Secondly, you must understand few points. The point one is that I want to make clear here, so it will help you in the exams. Both blocks move with same acceleration. Why? Because they're attached with each other. There is no other choice for them. Okay, they will have the same acceleration. Secondly, hanging mass pulls the system. This all movement is because of that mass. Okay, and one more point that is very important, that is very common mistake. The tension is not equals to weight. Okay, that is not equals to weight. Tension will be different. Okay, so you can't simply say that this tension is equals to weight and you can write it down 1g. That will be wrong. So these are the points you have to keep in mind. Please make notes of it, because the same question will be repeated in your May June 2026 paper. Okay, this is a pattern. This question mostly come, okay, in P1 or P2. Okay, so now let's try to solve it. What we have total mass. I have total mass that is 3 and 1 that is 4. This is the total mass. Okay. What the driving force is, I know driving force is weight of this block 2. So it is equals to 1g. Okay. I have to find acceleration. So from second law, we know F is equals to ma. So a is equals to F over m, right? So this F is what? This is the driving force. So that is the force that is responsible for all of the motion. Okay, so this is also resultant force as well. So you can write it down 1g and mass is 4. So this is acceleration. A is equals to g over 4. So that we got. Okay, but what we need relation for the tension. Okay, so now let's discuss for tension for T, what I can write, tension is, this is for block 1, okay, because that is the tension force acting on block 1, okay, and its mass is 3 kg. So what I have to write it down for this, if I write F is equals to ma, the force acting on it will cause the acceleration, and it depends on the mass of block 1. Okay, what I'm doing, I'm looking at this thing in isolation, just forgot there is anything else. We just have to look at this thing. There is a force T1 acting on it and its mass is 3 kg, and there will be an acceleration. What the acceleration is, for acceleration we have already solved the system by considering the total mass. Okay, so now you can understand this thing better, that a is equals to F over m, and this F is basically the tension and m is equals to 3, right? Okay, okay, I should not write it like this. I should, T is, F is T because we have to find T, m is 3, and a is, what the a is, g over 4. So this thing will give you 3g over 4. So let's look at the option. What we have, it is option C that is correct. Question 11. The mass of an object can be determined by its relation to other physical quantities. Three relations are given to you. Okay. What is the first relation? Resultant force on the object is acceleration. Okay, so this is coming from F is equals to ma, and if you divide F over a, you will get the mass. Okay. Linear momentum of the object divided by velocity. Okay, so P is equals to mv. So if you divide P by V, you will get m. Okay, so 1 and 2 are correct. Third is weight of the object divided by acceleration of the object. Okay, so W is equals to mg. There is a trick. This g is not mandatory equals to a. This can be equals to a if it is a free fall, right? But they haven't explained us that the object is falling freely or something. Generically, you can't say that whatever the acceleration of the object is, if you divide it with its weight, you will get the mass. It's not true. Okay, so this is not the case. Which relationship are always equals to the mass? No, they are not always. Okay, in some cases this can be true, but not for all the cases. Okay, like if, let me give you the example. Even if you take this example, this will not give you mass if you divide this thing with its, if you divide its weight with the acceleration, you will not get the mass. Okay, so it's not true in all the cases. So this is not the true. So it's option B that is correct. Let's move forward. Question 12. A basket is sliding on a horizontal frictionless surface with a velocity of 30. The mass of the basket is m, and the block of 2m is falling vertically. Okay, okay. So, what is this? Is two-dimensional momentum question, but they have tricked, like they are showing it like a linear momentum question. Okay, so if you see, this is moving in a horizontal plane and this is moving in a vertical plane. Okay, so what I'm going to do, and after colliding, they both will move like this in the horizontal. So what is important? What we need to do? We have to consider the horizontal plane for this thing. So if I try to solve this one, what I'm going to do, I'm going to take horizontal motion I'm going to consider. So what I know, total initial momentum should be equals to total final momentum. Okay. So horizontally, total initial momentum is just of this basket. That is 30 m. And after colliding, they are moving together. So it's mean this is the case whenever they are moving together, you just have to add the masses of both of them, that is 2m plus m, and you have to multiply it with the velocity that is common in both the cases, okay, because they both are moving together. So this v will be equals to 30m, and this 2m plus m is 3m, okay, divided by 3m. So this m will cancel out, this 3 1, and this is 10. So v is equals to 10 you have. This is option A. Question 13. Two children are balanced horizontally in equilibrium on a plank. Okay. The plank is uniform with a mass of this, okay, and length of 3 meters. There is a pivot at the midpoint of the plank. Okay, now look. The plank is what it's uniform and the pivot is at the mid. It's mean its weight is also acting here. So whatever the information we have for the mass of the plank, that is irrelevant in case of the movement. It will not create any movement, okay, because whenever the weight or the force acting at the pivot point, that force will not create any movement. This is the first point, okay. So you have don't have to consider any movement because of the plank's weight. Child X has a mass of 20 kg and distance of x, whereas child Y has a mass of 15 kg and distance y. You have to calculate the ratio. So we just have to consider this movement, that is clockwise movement, and this movement, that is anti-clockwise movement. That's it. So I can say clockwise movement should be equals to anti-clockwise movement. Clockwise movement will be 15 into why? Achha, I know the movement formula is force into the distance from the pivot point, okay? But even if you write down masses on the both side, it will make no difference in that case, okay? So you can write down if you want to, you can convert this thing in term of weight, 15 multiplied by g, and on the right side, 20 multiplied by g as well. But that will eventually cancel out with each other, okay? So 20 multiplied by x. What I need x by y. So let the x remain here, y you will bring on the right side, and 15 there, and 20 you will bring on that side. So x by y is 3 by 4, that is equals to 0.75. Okay, so it's option C, that is correct. Let's move forward. Question 14. Okay, this is also very repeated question. The diagram show two ways of hanging the same picture. Okay, in both cases, a string is attached to the same point on the picture and loop is symmetrical over a nail in the wall. The forces shown are those acting on the nail. The weight of the string is negligible. In diagram 1, the string loop is shorter than the two. Which information about the magnitude of the forces is correct? Okay. So this can also be discussed with the help of two-dimensional forces problem. One thing, there are two forces. One is there are two tension forces acting on it that we have to relate. Which tension is greater or equal or somehow we have to tell them. And we have to discuss about R as well. First thing you need to know, this R is acting vertically up. And there is only one force that is acting downward. That is the weight. And weight of the picture frame will remain same. It's the same picture because the mass of the string is negligible, so there is only mass of the picture, so that is same. So it's mean this r1 and this r1, they both are equals to weight, so they should be equal. We have to choose between A and B. Now let's look at T1 and T2, tensions in picture 1 and tension in picture 2. Acha. If I solve this one here, we know this is, if let's suppose if I discuss the T2, you can do this thing with T1 as well. T2 have two component. One component is this component and one is there. Okay. and one component is that way and one component is that way. Okay, and we know these two components are equals to, they should be equals to the weight. Okay, now what is happening, if you see, when this thing is more horizontal, when you increase the angle, what is happening, even if you see at the scale, you will see this line will be elongated. So when this line will be elongated, we can say its horizontal component will increase. Okay, so when this thing is like this, its tension in it, the horizontal component of it, will increase. So when this component, horizontal force component, increases, and vertical is same in both, so wherever there is more horizontal component, the total force will be more. Okay, so T will be more, so it will be option B, that is correct. Moving forward, question 15. The diagram shows four metal cylinders submerged inside a container of water. Which cylinder has the greatest pressure on the top of it? So you just have to keep in mind that deepest will have greatest pressure. Why? Because pressure is rho gh. It depends on this depth. So it's option C, that is correct. Question 16. Three solid object P, Q, and cylinder R are shown. Okay, which dimensions, the dimension and mass of the objects are given. Which object have the same density? Okay, what we have, we know density is mass over volume. Let's solve them. This will be m over volume is x into x into x, that will be equals to m over x cube for this one. So this is the density. For this one, mass is 4m and volume is x multiplied by 2x multiplied by x, so that is 4m divided by 2x cube, that will give you 2m over x cube. And for this one, we know, okay, it's a cylindrical shape object. Yes, it's a cylinder. So volume of cylinder is, what you can say, the area multiplied by the height, right? So it can be pi, radius is x square, and multiply by the height is this, x by pi. So I can say this pi will cancel out with pi, this will be x cube. So density is mass over volume. So mass is m and volume is x cube. So if you see this and this, they are equal. So P and R, it's option C, that is correct. Question 17. A small ball is projected into the air from the horizontal ground. The diagram shows part of the path of the ball. The ball leaves the ground at point x. This is the point x from where it is leaving, with the kinetic energy of this. So you have the kinetic energy at this point. It will have 8.0 joule of energy. A short time later, the ball is at a point y where it has a kinetic energy of this. Okay, so there is a kinetic energy that is equals to 3.5 joules. Okay, so and point y is that much above the height is given. A resistance is negligible, so you can say A is equals to G. What is the mass of the ball? You have to tell the mass of the ball. Okay, what I can do, I know this object is moving from here to here and there is no air resistance. Still, it is losing the kinetic energy. So whatever the energy it will lose, that will change into the potential energy, and luckily we have the height as well. So what we can do, the change in kinetic energy is equals to change in GPE. The GPE was here 0. Okay, and here the GPE will be mg into height, that is 8.8. So let's do this thing. So change in kinetic energy is 3.5 minus, sorry, the let it let keep it simple by subtracting the higher from the lower. Okay, it will not make any difference. So 8 minus 3.5 is equals to change in GP, so it is m, and g is 9.81 into height is 8.8. So m is equals to 8 minus 3.5 divided by 9.81 into 8.8. So that thing will give you 0.0521. Okay, so it is option B that is correct. Moving forward, question 18. A boat requires a power P to move through a still water with a constant velocity. There's a drag force affecting what is the velocity? Okay, so there is a simple relation P is equals to F into V. So V is equals to P over F. Okay, so it's option C. Moving forward, question 19. When the speed of the object is increased from 10 meter to 20 meter per second, its kinetic energy increases by E. Okay. What is the increase in kinetic energy of the object when the speed increase from 70 to 80? You have to tell the increase in. Okay, so we can use this thing by ratio proportion method. First, we have to look into what is the relation between the energy and the speed. Acha, they're talking about the kinetic energy. So we know kinetic energy E is equals to half mv square. Object have the same mass, so I can say E is proportional to v square, right? You know what is the scenario? The scenario is when v is 10, where v is changing from 10 to 20. Okay, what is happening? The energy change is equals to E. That is given. What I have to do, what I have to look into, they're asking when it changed from 70 to 80. So when it changed from the first, we have to do this thing as well because it is square with it. So it's 20 square minus 10 square. So change is 400 minus 100, that is 300. Okay, so in term of square, the change in the velocity, because we are finding the energy is proportional to v square, not the v. So that is a change for the energy, that number we got. Okay, so for 80 to 70, what I have to do, 80 square minus 70 square, that will give me 6400 minus 4900. This thing will give me 1500. Okay, so this is the change for that thing. So one is 300, one is 1500. So 1500 divided by 300, I have two ratios for both of them in terms of v square, because v square is proportional to e. I will get 5. So it's mean there is a 5 time more change. Okay, so it is C. Question 20. Train supply coal to a power station. The table shows quantity describe the operation of the power station. Okay. Which expression give the efficiency of the power? Okay, so for the efficiency, we have two options. You can say power, useful power output over power input, or you can say I can say energy useful power, energy output over energy input. So let's look at what options we have. So we have power. There is no power on the numerator, so we are not using this relation. Okay, most probably we are using second. Let's see. Energy is basically equals to power into time. So power is p and time is n. So this should be pn. Yes, we have. No, sorry, it is not n. The time is s, so it should be ps. Yes, so output power, this is the power out. This should be efficiency ps over p in. Okay, so I think we don't have to solve it further because this is the answer. This is the only option. How we have Pn is equals to, just for your understanding, is equals to nme. Why? Because this e is representing this thing, energy of 1 kg. Okay, so when you multiply 1 kg with m, so basically me is giving you energy of one train. And when you multiply nme, what is n? N is basically this thing, number of trains. So it is the total energy from all trains. Okay, so this is how it is making sense. Let's move forward. Question 21. Which description of the object undergoing elastic and plastic deformation? Elastic deformation is when you remove the load, the object will go back to the original shape, and plastic is it will not go back to the original shape. So it is option D. 22, a force F extended a length L of the uniform wire. Okay, the Hooke's law diameter is D, Hooke's law is D. What is the Young modulus? Okay, so we know Young modulus is equals to stress over strain. Stress is force over area, strain is change in length, that is E over original length, that is L. So you can write as F into L divided by A into E. But we don't have answer in term of A, so we have to change it. And we know area is pi r square, or it can be written as pi d square by 4, because r is equals to d by 2. D is the diameter. Okay, so you can put this thing f l over a is pi d square over 4 e. That will give you 4 f l over pi d square e. Pretty easy. So this is option D. Let's move forward. Question 23. An 8 Newton weight is attached to the lower end of the spring, which is fixed at its upper end. Okay, they are fixed from here. The weight is initially held at a stationary at a rest at a position x, that is x, and the spring is unstretched. The weight is then released to fall to the position y, this is y, which is 4 centimeter below x. The weight oscillate and then eventually come to the rest at position o, that is 2 centimeter from x. Okay, let's see what they're asking. How much energy is lost? Okay, pretty easy. It was initially at this point, and after doing all of the work, it is reaching at this point. So there is a change in height. So first thing that comes into my mind, there is a change in potential energy. How much change? It is moving from this to this. Okay, so change in height is 4 minus 2, that is 2. Okay, so 2 centimeter, that is 0.02 meter. That is a change in height. So energy loss is basically equals to change in potential energy, that is mg delta h. We have m is 8. We have this mg is 8. This is the weight, right? So 8 multiplied by 0.02, that will give you 0.16. So this is option C. Question 24, an electromagnetic wave has a frequency of this. Which principal region of electromagnetic spectrum is this wave is? This is in IR. Moving forward, question 25, a wave on the stress string causes the particle on the string to vibrate. The diagram shows the part of the string at one instant, PQR of the particle on the string. Which statement about two of the particle and the wave is correct? If it is a progressive wave, P and Q vibrate with a phase difference of 90. No. If this is a progressive wave, this point and this point will be at a phase difference of 90. Q will be at a less than 90. Okay, so this is not correct. B is, if it is stationary wave, particle P and Q vibrate with a phase difference of 90. P and Q. No. If it is a stationary wave, whatever particle is in this region they will be in phase. Okay, but you have to keep in mind there is an important point. In stationary waves, mostly students do this mistake. Waves, nodes are 180-degree out of phase. There is no other option. So you can say P and R are 180-degree out of phase. Okay, P and Q are in phase. So if a stationary wave particle P and R vibrate with a phase difference, okay, this is the exact thing. Okay, move forward. What describe the displacement of a particle on a wave? Okay, so distance in a specified direction of the particle from its yes, this defines it. Question 27, a beam of vertical, this is from the polarization, I believe. A beam of vertically polarized light as an intensity of I naught is incident normally. Okay, so there is the light coming, that is I naught. The transmission axis of the filter is set at 60 degree. Okay, the light is coming that is already vertically polarized and this angle is with it, 60 degree. So whatever the light will go here, we have a relation I is equals to I naught cos square theta. So the light that will come out of this thing, that will be, let's call this I1, that will be equals to I naught cos square 60. Okay. Now what they are telling, the transmitted light beam is incident normally on a second polarizer. The transmission axis of the second polarizer is perpendicular to the vertical as shown. Okay. The intensity of the light beam that emerged from the second polarizer is IT. Okay, so from where this there will be a light IT, and you have to tell what this IT is. What you have to tell what this ratio is in term of I naught. So IT will be equals to I1 because the light coming here, this is I1 cos square, what the theta is. If you know when the light, this light that is coming here, that is already at 60 degree to the vertical. So the light is coming like this at a 60 degree. So this angle will be a 30 degree. Okay, if it is horizontally. Okay, so this is the 30. So you will get cos square 30. But we need the answer in term of I naught, so I have to put the value of this thing. So I can say IT is equals to, this is value of I1, I naught cos square 60 into cos square 30. So IT over I naught is cos square 60 into cos square 30. That will give you 0.19. It's option B. Moving forward, question 28. A car is driving along a straight road while emitting a sound of constant frequency. There is a stationary observer at each point x, y, z. Okay, what we have to tell, from x to y the car accelerate. Okay, so from this to this it is accelerating. So I can say speed increases. Okay, then which observer hear the highest sound? Acha, from y to z it is moving with the, from y to z. This is, let me highlight this. This point is constant highest speed. Which observer will hear the highest frequency sound? Okay, there are two factors for the highest frequency sound. Frequency depends on the speed. Okay. So what we know, they're asking us, there is another technical point. They're asking between, not at a point. If you see, this car is moving away from the X. So X will receive a lower frequency for all the cases. So X is out of the option. Okay, so this is not the choice that you can choose. We have to choose between Y and Z. So for Y, when it is moving between X and Y, it is going towards the Y. So the frequency will increase. It's moving towards. Whenever move towards, frequency increase. When move away, frequency decrease. So between this increase, but between it's constantly increasing speed, but highest speed is at y, not between x and y, because it is increasing its speed till y. But if you see the factor z, When it is moving here, it is also moving towards the z and at a constant highest speed all the time. So when it reach at this point, it will already have the highest speed. That was not the case for the y, because when it is reaching the y from the x, it was accelerating, it was increasing speed. But when it is reaching z, it is already at a highest, at a peak speed. So it will, the z, the observer at z will hear the maximum frequency. Okay. Moving forward, question 29, each diagram shows stationary wave. Which diagram is correctly labeled? Okay, these are not the nodes, so this is not the option. This is antinode, this is node, but this is not the wavelength. Okay, so this is not the option. Um, this is not a node. This is antinode, this is node, and this is the wavelength. Okay, so option D is correct. Moving forward, question 30. Two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. Okay, there are two very important points. They are electromagnetic waves and traveling in a vacuum. They will have same speed. Okay, the two wave meet at a point and they are coherent as well. So coherent mean they will have a constant phase difference, but they have a different intensities, so they will have different amplitudes. Okay, so very easy to choose this option. Which statement of the wave is not correct? You have to choose not correct. So B is not correct. They have the same, no, they have this different amplitude. 31, laser light of the single frequency is incident normally on a single, on a diffraction grating with this much lines, this lines per meter. So here you have the n. A diffraction pattern is formed on a flat screen which is parallel to the grating. The screen is a distance. Okay, let me draw this diagram. So first we have, let's suppose this is the grating, and this is, we have the screen. Okay, the screen is at a distance of 3.3, okay, 33.3, sorry, my bad. It is 33.5 centimeter. The distance between the two first order intensities is 15. Okay, two first. We know there is, at this point, this is n is equals to 0. At, let's suppose this point, n is equals to 1. At this point, the n will also equals to. So the distance between the two first order is telling you this distance. So this is given, it is equals to 15. Sorry, let me remove this. This total is from here to here is 15.0 centimeter. What is the wavelength of the light? You have to find lambda. Okay. What we have, it's a diffraction grating question. We have a relation n lambda is equals to d sine theta. Okay, first I have to find d. D is simply, d you can say is equals to 1 by n. So this can be written as 1 over 5 into 10 raised to power 5. Okay, whatever the answer is. Okay, what I need else, we have to find lambda. Let me read, lambda is equals to d sine theta over n. If I take this as a first order, then n is equals to 1. Okay, what we are left with, we need theta. How you can find theta? For theta, you have these two lengths given. So what is the theta? Basically, if you know the definition, theta is this angle. Okay, so what I can do, I have a triangle, if you see, like this thing will be, this total is 15, so this will be a half of 15. So this is 15 divided by 2 is 7.5. So this is 7.5 centimeter. This is 33.5 centimeter, and you have to find this theta. You can use the trigonometry. Actually, you can find the theta or you can find the sine theta directly, because we have to put here sine theta. So I prefer to find the sine theta directly. So I know sine theta will be perpendicular over hypotenuse, you can say. So it is 7, let's call this h, 7.5 over h. And we know this h will be equals to, by applying Pythagoras theorem, can be written as under root 33.5 square plus 7.5 square. Okay, you don't have to convert the units, they will cancel out with each other automatically because this is a ratio now. Okay, so when you do this you will get 0.218, that is sine theta. So now we have sorted all of the things. Now I can put the values here. Lambda is equals to d is 1 over 5 into 10 raised to power 5. Sine theta is 0.215218, sorry, and n is 1. So when you solve this thing, you will get 4.3710 raised to power minus 7. Okay, what the options are in nano. So I can change this thing to 437 into 10 raised to power minus 9, or it can be written as nanometer. So this is option A, that is correct. Moving forward, question 32. Which graph represents the variation with current I of potential difference for a filament lamp? What you need to know, in a filament lamp, voltage keep on increasing and I will not increase at same rate, or you can say it will be constant at some point. So if you read the graphs you will see B is only representing that thing. Okay, potential difference can increase because resistance is increasing in filament lamp. So whenever resistance is increasing, it will make harder for the current to flow. Okay, and potential difference will keep on increasing with velocity, with resistance, sorry. Question 33. What is the definition of potential difference across a component? Okay, it's the energy transfer per unit charge. Very easy. Okay, so question 34. Conducting putty is a substance that conduct electricity and can be molded into various shapes. A cuboid made from this putty has a length L and a width X. The resistance between the square faces of the cuboid is 15. Okay, so you have the resistance. Some more of the putty is molded into the cylinder that has the length of L by 2. The resistance between the cylinder face is okay, so both have the same R. What is the radius of the cylinder? So let me make the diagram here. Okay, what type of cylinder this is? This is cylinder, its length is L by 2. Okay, and this, what we have to find, we have to find the radius. So this is the midpoint, this is the R, so its area will be pi R square. Achha, both have the same resistance. So we know resistance relation is rho L over A. Okay, and for this A is, for this thing, rho L over, it will be X square, X into X. This will be the area of it. Okay, and for this, the R will be equals to, it's the same putty. So resistivity will be same. Length की जगह पे L by 2 आप put करेंगे and area की जगह पे come pi R square. Okay, what we can do, we can, this is 1, this is 2, we can equate both of them, and what we'll get, rho L over X square is equals to rho L over 2 over pi R square. So what I can do, okay, so what we can do is this rho will cancel, this L will cancel, and this will be 1 over X square is equals to 1 over 2 pi R square. So I can say 2 pi R square is equals to X square. So R is equals to X over under root 2 pi. Okay, it's option B. Question 35. Each of Kirchhoff's law is linked to conservation of physical quantity. Which conserve physical quantity are used in first and second? Very easy. In the first, we use conservation of charge, and in second, we use conservation of energy. Question 36. 8 identical resistors are connected as shown. Ammeter A1 reading is 1.5. Okay, so this reading is 1.5 ampere. What is the reading on ammeter A2? Okay, there are different methods to solve the circuit. What I see best is, you see the resistance, they are all identical. So if there is a resistance R, there is R and there is 2R. So when the current is coming from here, the current have two choices. It will split. It will go where the resistance is less. So if it is going here 1.5, at this point resistance is double, so the current will be half. So at this point, the current will be going from here will be 1.5 divided by 2, that will be 0.75. So this current that is coming from here, this will be the total current, that is 0.75 plus 1.5. That will give you 2.25. Okay, so the same current will be coming from here. That is 2.25. Okay, so now we can deal with this thing. Now when this current will reach here, it will see yaar yahan pe to two resistances hain and there are three resistances. It will divide. It will go more where there is a less resistance and less where there is a more resistance. But it's not that simple. Half to double correlation to nahi hai. There is a fraction. So we have to make the ratios now. What I can do, I know two equation. One is now I'm looking entirely on this scenario. Okay, just forgot this thing, the right portion. We are done with it. We know I1. Let me call this one as the current going from there is I1. The current going from there, let's call this I2. I know this I1 plus I2, it should be equals to 2.25. That is coming from battery. Okay. Now I know I1 is inversely pushed to resistance, and in the path of I1 resistance is 3R, R plus R plus R, that is equals to 3R. And same is the case for I2, that will be equals to 2R. Now what we know, the ratios should be, we can equate the ratios. Okay, so I1 over I2, we are using ratio proportion method, will be equals to 1 over 3R over 1 over 2R. So that will give you I1 over I2 is equals to 2R over 3R. R cancel. So I can say I1 is equals to 2 into I2 over 3. Okay. So what I can do, I can put this value where? Back to this equation. I will get the answer. How? Let's do it. So what I can do, I1 is 2 I2 over 3 plus I2 is equals to 2.25. So this thing will, when I take the LCM, give me 5 I2 over 3 is equals to 2.25. So I2 is equals to 3 times 2.25 divided by 5 is equals to 1.35. 1.35. It's option C. Perfect. Question 37. A battery of electromotive force 6 watt and negligible internal resistance is connected in series with a resistance of 6 ohms and a variable resistor of resistance that varies from 0 to 4. Okay, a voltmeter is connected across this variable resistor. The resistance of the voltmeter, the resistance of the variable resistor change. What is the range of the voltmeter reading? Okay, so there are two scenarios. This, let's call, we can name them, let's call them R1, let's call this R2. We know this R2 can go from 0 to 4. Okay, let's find the current first. If I find the current, the range will be for voltage of this, let's call this voltage V. When this is 0, this voltage will be 0, because we simply know V is equals to IR. When there is no resistance, there will be no potential difference. Okay, so what thing we know, that this thing will be 0. So we have to choose between A and B. And when this is 4, when resistance R2 is 4, what will happen? For this thing, we have to find R total. What we are doing for R2 is equals to 4. Okay, so our total is R1 plus R2, that is equals to 6 plus 4, that will give me 10. So total current is total voltage over total resistance. Total voltage is 6, total resistance is 10, is 0.6. So if I have to find V2, the reading of the voltmeter, it will be total current that is passing through both the resistances multiplied by the R2. So 0.6 multiplied by 4, that thing will give me 2.4. So that is a range. It's option A. Question 38. In alpha particle scattering experiment, a beam of alpha particle is aimed at a thin gold foil. Most of the alpha particle goes straight through or deflected by a small angle. A very small portion are deflected by more than 90 degree, effectively rebounding towards the source of alpha. Okay, which conclusion about the structure of the atom cannot be drawn? Okay, first, most of the atoms atom is the empty space. No, we can draw it because most of the alpha particle were moving straight through it. B, most of the mass of the atom is concentrated in it. We can draw this conclusion. Okay, so this is also true. We have to select which one cannot be drawn. The nucleus contains both proton and neutron. Okay, so we don't know about the neutron anything because neutrons are neutral. They're not going to repel the alpha particle as well. So neutron existence will not be verified by this thing. So C is the option. 39. In type of beta decay, an up quark changes flavor to a down quark. Which row show the new hadron created in this beta decay and the sign of the charge on the emitted beta particles? Okay, so what they are saying, up quark change into a down quark. So when this happen, first thing you have to keep it is happening in beta positive decay. If you remember, the up quark change to down quark plus it will emit the beta positive plus it will have the electron neutrino. Okay, so this change proton to neutron. So it's option A that is correct. 40. A uranium 23892 decay into a radium after a sequence of alpha and beta. Which row give the correct number of alpha and beta minus? Okay, it's a very common question. We know alpha is 4 2 and beta is 0 minus 1. So if you see, whenever alpha is decayed, sorry, whenever beta is decay, it will not affect the mass of something. So first, with the help of this alpha, we can easily, with a change, by looking at the change in mass, we can easily count the alphas. Then we can deal with the betas, okay, because the mass is only affected by alpha. So let's deal this thing first. We know U23892 is changing into this thing 226 88 plus it have some alphas, let's call them x and y betas. Okay, this alpha is 4 2, this beta is 0 minus 1. Okay, you can also make the equation from it. What I can say, 238 is equals to 226 plus x times 4 plus y times 0. So what you will get, 238 minus 226 divided by 4 is equals to x. Let me do this. So how we can do, 238 minus 226 divided by 4, that will give me 3. So we know x is 3. Now when you will apply the balancing of equation on this charges, what you will get, 92 is equals to 88 plus x times 2 plus y times minus 1. So 92 is equals to 88 plus x is already 2 and this is minus y. So y is equals to 88 plus 6 minus 92. Let me solve this. So this will give you 2. Okay. So alphas are 3 and betas are 2. It's option B. Okay, so you haven't, if you haven't like and subscribe the channel till now, please subscribe it so we can be in touch for the next videos. Thank you.